5 we did part A, right? Now we have to do part B. Part B is beta a cylinder of volume 5.0 times 10 to the power 3 cubic centimeter contains air at a pressure of 8.0 times 10 to the power 5 Pascal. Okay, a leak develops so that the air gradually escapes from the cylinder until the air in the cylinder is at atmospheric pressure. The pressure of the atmosphere is 1.0 times 10 to the power 5 Pascal. Calculate the volume of escaped air now at atmospheric pressure. Assume that the temperature stays constant. Now, beta, see, when you read the question, when you have to solve a question, when you read it question, okay. So, beta, obviously, you should start recalling the concepts you have studied. Okay. Now, beta, after reading this question, can someone tell me how can we solve it? What information is given, and how can we use that information to find the answer? Can
Sir,
anyone tell?
sir,
Ji beta.
pressure 1 and volume 1 is given and pressure 2 is given. So we'll use the equation P1 V1 is equals to P2 V2.
Very good, beta. Very good, Noor beta. Shabash. So, beta, here we are given the volume. Actually, the question says volume, a cylinder of volume 5.0 times 10 to the 3 cubic centimeter contains air. So we know that beta air basically, or gases, they do not have fixed volume. They fill the container they are in, right? So if the volume of air, the volume of cylinder is this, and this volume of cylinder contains air. So it means the volume of the air is also this. Right or wrong? Right or wrong, beta?
Yes, sir.
Okay, and then we are given the pressure of the air. So we are given at an instant that this is the volume and this is the pressure. So we can say P1 V1 are given, and then beta a leak develops. So beta air gradually escapes from the cylinder until the air in the cylinder is at atmospheric pressure. Okay, and that means so when the cylinder there is a leak. Okay.
Sir, did you share this
जी बेटा.
worksheet? Did you share this worksheet?
Yes, beta. I have shared this worksheet with you. Okay. Now, beta, this is a cylinder. When leak develops, beta, so air inside that escapes, right? And beta, so until the pressure is inside the or pressure of the air in the container is equal to atmospheric pressure. Means atmospheric pressure means surrounding pressure, right or wrong? And we are given the atmospheric pressure. Now, beta, we know this is V1, volume 1. This is P1. And this is P2. Now P2 means all the air is at this pressure, right or wrong? And beta, see, calculate the volume of the escaped air. Volume of the escaped air, right? Now beta, we use this P1 V1 equals P2 V2, right? Beta, when the volume of the air is 5.0 times 10 to the 3 cubic centimeter, its pressure is 8.0 times 10 to the power 5 Pascal. So beta, we can write P1 V1 8.0 times 10 to the power 5 Pascal. Okay, times 5.0 times 10 to the power 3 cubic centimeter. P2 is 1.0 times 10 to the power 5 Pascal. Sorry, no need to write the unit here. And V2. Now beta, here two things important. First, beta, here we know Pascal is equal to what, beta? Pascal is equal to Newton per square meter, right or wrong? Right or wrong, beta? Beta, yes or no?
Yes, sir.
Okay, and beta, pressure is in Pascal and volume is in cubic centimeter, right? See? So beta, actually it should be same. It means if pressure is in Pascal, volume should be in cubic meter, right or wrong? Now beta, here we don't need to do that. We don't need to convert the unit. And you know why? Do you know why, beta? I'm telling you a point, beta, because here on this both sides volume, right, beta? Simple. If we do not convert the volume in cubic meter, here we'll find this volume in cubic centimeter. Getting my point or not? So since it's both side, there is volume on both sides. So to convert cubic centimeter to cubic meter, we have to, you know, do the same things on both sides of the equation. So that will basically leave the equation as is. So that's why I'm not changing it here, right or wrong? Right or wrong, beta?
Right.
But if you just have to multiply pressure and volume, okay, pressure and volume in any case, let's say, and pressure is in Pascal and volume is in square cubic centimeter, or similarly, if you have to find the force, okay, and then you are given the this equation, use pressure times area. In that, if pressure is in Pascal and area is in square centimeter, then you have to convert square centimeter into square meter, right or wrong? Getting my point or not? Beta, getting my point or not? Beta, Shabash,
Yes, sir.
respond.
Got it, sir.
I'm trying to explain a point. But here, I'm not doing it because we got volume on the both sides of the equation. Okay? So, beta, now we find V2. And now, beta, another important thing. You must understand and you must remember this. This equation, what does it mean? It means, beta, basically, this is a Boyle's law. That, beta, a certain mass of gas, a fixed mass of gas, for a fixed mass of gas, when the volume of the gas is 5.0 times 10 to the power 3 cubic centimeter, its pressure is 8.0 times 10 to the power 5 Pascal. Now, for the same mass of gas, if the pressure is 1.0 times 10 to the power 5 Pascal, what would be the volume of the gas? This is what it means now. This is what it means, yes or no? जी बेटा
Yes, sir.
Okay. So beta, now we find the V2. We find the V2, and beta, you should understand what is V2. V2 is the volume of the same mass of gas, right? Same amount of gas when the pressure is 1.0 times 10 to the power 5 Pascal. Okay. And this is important to understand. You will now in a moment why I'm saying this. Shabash beta, what do we get? What is the answer? Shabash beta? What is the answer?
Sir, 4,000.
Beta, do it correctly. I don't think it's 4,000. Anyone else done?
Sir, 40.
Sir, 40,000.
40,000. So it's 40,000 cubic centimeter. Now understand, beta, now V2 means, beta, for the same mass of gas, okay, it means we are talking about a certain mass of gas, okay, and that fixed mass of a gas has a volume. When its volume is 5.0 times 10 to the 3 cubic centimeter, the pressure is 8.0 times 10 to the power 5 Pascal. And beta, now if the same mass of the gas is does have 40,000 cubic centimeter volume, its pressure is 1.0 times 10 to the power 5 Pascal, which is equal to atmospheric pressure. Clear or not? And well, now tell me, is it what we are looking for? Do we have to find this? The question says calculate the volume of the escaped air. Means then is 40,000 our answer?
Yes, sir.
No, beta, this is not the volume of the escaped air, right? Because it means this is the volume of all the gas. Now this will be the volume of the gas when it will cause a pressure equal to 1.0 times 10 to the power 5 Pascal. Means all the gas mass does not change. You remember that or not? But beta, when the leak develops and gas escapes from the cylinder, does all the gas escape from the cylinder? And
No,
question
sir.
even gives you a hint that a leak develops so that air gradually
Sir,
escapes
sir,
from the cylinder
still
until the air in the cylinder is at atmospheric pressure. It means when the leak develops, obviously all the air will not leave. There would be some left. Means it will leave unless until the pressure inside, means in the cylinder, is equal to the outside, which is atmospheric pressure, right or wrong? So obviously there would be some some air still left in the cylinder, right or wrong?
Yes, sir.
So we have to find only the volume of the escaped air. And now beta, what will be the volume of the air left inside the cylinder?
Sir, 40,000 cent.
No, beta, that is the beta. No, that's what I'm saying. Now you need
The
to
half
understand
of
what does.
40,000.
No. Beta, uh, this 40,000 means we have a cylinder. Please listen carefully. Okay, we in that cylinder contains a fixed mass of a gas, right? Okay, and beta, now let's say this is the volume of the gas, and this volume, this is the volume of the gas. At this volume, the pressure is 8.0 times 10 to the power 5 Pascal. So beta, here the volume is 5.0 times 10 to the power 3 cubic centimeter, and beta at this the pressure is 8.0 times 10 to the power 5 Pascal, right? Now beta, this 40,000 means that it's if we increase the volume of the gas, so its volume now becomes 840,000 here. Now if it becomes 40,000 cubic centimeter, beta its pressure would be 1.0 times 10 to the power 5 Pascal, right? This is what it 40,000 mean, right? Means without any change of mass. Getting my point or not?
Yes, sir.
But beta, when leak develops, air leaks, so some mass of the air is leaving the cylinder. Getting my point or not?
Getting it, sir.
Okay. Now beta, so obviously it's like air or gases. Like I told you, the volume of the container they are in is their volume, right? So the volume of the air inside the cylinder will be what? It will be the volume of the cylinder. Right or wrong? Beta, right or wrong?
Right, sir.
So beta, the volume of the escaped air, can someone now tell volume of escaped air would be 40,000 minus 5.0 times 10 to the power. The volume of the cylinder 10 to the power 3. And beta, what do we? Shabash beta.
Sir, 35,000.
G 35,000, and beta that is the answer 35. And beta here we don't need to write the unit because it's already given 35,000 cubic centimeter. Got it beta?
Yes, sir.
Beta, is that clear to everyone?
Yes, sir.
Next question beta. Figure shows the quantity of gas in a cylinder fitted with a piston. Describe the motion of the gas molecules of the gas, and beta this is 3-mark question. So can anyone describe the motion of the molecules of gas, considering in mind that it's 3 marks question? Shabash beta.
Or the Brownian motion or the kinetic motion?
Brownian motion and
Kinetic motion.
beta, kinetic motion is nothing. Kinetic is related to motion. Kinetic energy is basically the energy that an object has due to its motion. They are moving, so they have kinetic energy. Okay, so kinetic motion is not a term. Okay, fine. And what do we mean by Brownian motion?
Sir, the
The
zigzag
movement,
movement
the
of the
random,
molecules.
the random movement of
Beta,
molecule.
Brownian motion basically means random movement. Okay, that's how we define Brownian motion. Now, how did we define Brownian motion? It's the random zigzag motion, right? So you have to tell about the motion now. So tell about that. So we know, and if you remember the kinetic theory we studied in chapter number 17. So gas molecules, they move randomly and at high speeds in different directions or all directions. Okay, and what else do you know about the molecules in the gas, how they are moving?
They collide with each other.
They collide with each other and with the
Changing momentum.
no beta, with the walls of the container.
Wall of the container.
Shabash. So I think now we got 3 points. 1 mark for writing they collide with each other or with the walls of the container. Second, they move randomly, and third, about their speed, they move at high speeds. They have high speed, right or wrong?
Right, sir.
Yes, sir.
So this is what you will write in your answer. Molecules of the gas move randomly at high speeds in all directions and they continuously okay beta, the piston is slowly now pushed, and here beta, since they have told continuously collide with each other with the walls of the here they have said piston fitted with P. So instead of the container we can use the word cylinder, right? Because we are know the container is cylinder. Now beta, the piston is now slowly pushed down to decrease the volume of the gas. The temperature of the gas does not change. State and explains in terms of molecules what happens to the pressure of the gas. So beta, state and explain. First of all, state what happens to the pressure.
So the pressure increases.
Very good. And beta, now explanation. Explanation. Beta Shabash, explanation. Can anyone give the explanation, beta?
Sir, the pressure of the gas increases as they have less area to collide, less space to collide. So, sir, they collide more fast and the pressure increases.
Yes. So beta, see, this is 2 marks. 1 mark is for statement and 1 mark is for explanation, right? Pressure of the gas increases. Okay. Okay, because when the volume of the gas decreases, there are. So beta, this is just for 1 mark, so then it is enough to write this. Otherwise, we don't need to go, like we don't need to write there. We can write if you want, but considering the space and the marks, I'm just leaving this these points that there will be more number of molecules per unit volume would increase. So then, so I'm just leaving this point. So the number of collisions per second increase. I'm in writing this point. So there are more frequent collisions between the molecules and what beta, and the walls of the cell under, right? Clear beta? जी beta, clear?
Yes, sir.
Okay beta, so beta, the time is up, so I'm going to conclude the class here. Inshallah, rest we'll discuss in our next class. Beta, you go through the test, your tests are checked, and beta also will discuss the test in the next class. Okay beta? Okay beta, Allah Hafiz.
Okay, sir. Allah Hafiz, sir.
Laughing.